You're just waiting for that? I had a student a couple years ago, Jake Wirt, who would wait for me to click on the recording, and he had like a gong sound that he would play. It's just yeah, students have all sorts of recordings of things I've said in the past. You guys haven't, I haven't like finished getting you fully acclimated to me yet, so I haven't done some of my antics yet. So it'll catch you by surprise at some point. Okay, so let's power through the rest of this stuff. So we started talking about our web technology stuff. We talked about this idea of client side versus server side. We drew a picture of this guy, right? And client side has a, sometimes it's called client side, sometimes it's called front end. But if you're ever looking at developer jobs, when they say client side or front end stuff, they're talking about making things look pretty. They're talking about the stuff that actually shows up in your web browser. Back-end stuff or server-side stuff is the stuff that's happening on the actual web server side of things. We talked about MIME types, which is the extensions on these guys. So when a browser makes a request using the HTTP protocol to a server, it's going to be requesting a file. That server is going to look at the MIME type of the file and decide, do I need to do something special with this file before I send it back, or do I just send it back? If the MIME type is just HTML, text/HTML, the server will just go and grab the file from its hard drive, wherever it is, and spit the answer back to the browser because that file's already in HTML and JavaScript, which is what our web browsers understand. If it's one of these other guys, that means that that file contains a program of some type. And therefore, the web server has to send that file over to the correct preprocessor module to run that program, whose output should be HTML and JavaScript. So once the web server receives the output of that program, it will then send the output across the internet over to the browser. All right, so that's in a nutshell how the internet works in terms of the web. Make sense? Now, our choice for the programming languages that can live over here. So HTTP isn't a programming language. This guy is a protocol that web browsers speak to web servers. And we could also leverage this in some of our other applications. And like you could have an iPhone or an Android app that chooses to speak HTTP to a web server. So you could actually receive requests from a web server and parse out the HTML yourself and do things like that. So you can pretend to be a web browser making requests as if you're a web browser, even though you're not a web browser. You don't intend to actually put the stuff on the screen. Maybe you have a web page that has a bunch of information on it. We've had some students write apps in the past for their favorite video game, for example, where there might be a website for the game, and that website has a bunch of information about the game on it, or stats and updated stuff, things like that. But the site doesn't specifically expose something called an API. So let's throw that on a slide here. API is an application programming interface. It's a fancy way of saying a way to access their data legitimately. All right, so for instance, if I'm writing an application that is talking to Shopify, for example, it's an application I'm working on right now. Shopify has their own API, which allows developers like me to write a program and use their official means for requesting information from their website. So I can get customer information and information about orders that were placed, stuff like that, officially. Now, for other websites that maybe don't expose this information, either because they don't want you to publicly have it, or they just don't have an API, they have no interest in that, or they don't think they're a big enough market to spend money on creating an API, so that because people don't want to write apps for it, which is often the case for some of these starter video games or something like that, a game that's somewhat popular within a single group or something. Well, if a student is interested in pulling stats into a mobile app or something like that from this game, and if you go to the game's website and those stats are just available on the site, what you can do is you can do what's called screen scraping. So you could have your app pretend to be a web browser, make a HTTP request to your game's web server, ask for the page, and then you fish through and pull out the little bits of information from the HTML that you're interested in, and then you could put it on your mobile app screen however you want. So it's kind of strategies. It's not, there's nothing illegal about it unless the data that you're accessing you're turning around and reselling, and that's against their terms. Actually, I have an interesting backstory to that. When the Apple App Store first went live, I wrote 2 different applications for it. One was called Quotes RT, the other one was called Portfolio RT. And they were the first 2 real-time stock quote applications. So you'd open up your phone and you could put in all the different stocks you were interested in, and it would update in real time and kill your battery. Because it was constantly hitting the website, screen scraping information. I was using Google Finance as my source, because at that time, this was 10 years ago, 11 years ago, none of the stock exchanges had that data available. So I didn't have another option. Well, I did pretty well with the app, but I was screen scraping. So I was asking Google Finance for the web page for a particular ticker symbol, and then I was pulling out the price and all this other information from it and presenting it on the screen. Well, after I was probably up there for about a year and a half before the App Store really took off and everybody decided they needed an app. So then I got a message from the NASDAQ and the Dow Jones, desist, take your app off the App Store, you're breaking our rules, because they had instantiated new rules that said that data was no longer publicly available. You have to now pay for it. Well, at that point, E-Trade and all these other guys had already started putting their apps up there, so I was no longer the only kid in town, so you shut down shop instead of trying to compete with them. So I'd already gotten dollars out of it. But there's examples of how you might use APIs or use HTTP to talk to a web browser, but you do need to be careful about acceptable use of the data and that kind of stuff. So, something to consider. But in any case, HTTP is it's Hypertext Transport Protocol, and anything that has the word protocol at the end of it in computing is a language. It's just a fancy way of saying a language, no different than English or Spanish or anything like that. It's the language that 2 endpoints use to speak with each other. Okay? And that language typically has constructs in it that allow them to do the stuff that they usually do. So a web browser requests web pages. So the HTTP language is actually quite small. They have 4 different things they can do. They can get something, they can put something, they can post something, and they can delete something. Everything they do is in terms of those. All right. Kind of along those lines, when we talk about APIs, there's the current cool kid, let's say, if you've ever seen some of these buzzwords. And a lot of these I'm throwing out here are buzzwords that are all over kind of the development community in the world. So some of you, if you have been into that stuff, will recognize these others. Well, this is the first time you've seen these words, so if this is foreign to you, don't worry about it. But we have these things called REST, or sometimes they're referred to as RESTful APIs. Anybody ever seen either of those words before? REST APIs or RESTful APIs? Let's call it the current cool kid, but the irony is historically this idea of an API having, let's say we have 10 different companies, and these companies want to have a means to share their data with you. Certain data, maybe just data they want to have publicly accessible. Maybe they're not sharing credit cards and stuff like that, but they might have a portion of their data that they want to make available to developers, because developers might want to run apps that provide that information to consumers, and that helps this company, the back-end company, because, people, for instance, PayPal has an API. Well, it's in their best interest to have as many apps out there as possible that will accept PayPal payments, right? So if you could embed PayPal payments into your application without sending them over to PayPal, that makes life easier for your consumers and still makes PayPal money. So they're happy to do that. Well, historically, as APIs first were kind of coming out, let's call it, 15 years ago, something like that, even 20 years ago, they each had kind of a proprietary format. So if you wanted to use PayPal's API, you had to figure out how to speak their lingo. If you wanted to use Starbucks API, you had to speak their lingo. So they all had just different standards. Then we started moving towards a standard, and there was this early standard called SOAP, which some companies followed SOAP strictly, some kind of loosely followed it. So at least as a developer, you had a rough idea how to talk to a company's API when you started writing it, but it wasn't necessarily consistent across all companies, but you had a starting point. Well, this idea of a REST or RESTful API is the current cool kids standard, where talking to this API or that API or that API is absolutely identical. They might have different pieces of information that they are exposing. So this guy might have 10 different endpoints, 10 different things that they're willing to provide you. This guy might only have 3. All right, but the means by which you ask for those 10 things are identical to the way you would ask for these 3 things. All right, so that's our standard, and that's called a REST or a RESTful API. Now, what's interesting is this is the current cool kid, but it's actually based on something that's been around since the birth of the internet. RESTful APIs are based on HTTP. So I just mentioned that HTTP have 4 functions. We have a get, we have a post, we have a put, and we have a delete. Now the reality is only 2 of these have really been used for years and years and years. Whenever you type in your web browser and say www.google.com or something like that, that generates a GET request. A GET request retrieves existing info. In this case, it retrieves the Google homepage, or it retrieves the current specials at Starbucks, you know, that kind of stuff. A post updates, actually, I'm sorry, creates new info. So where posts are used today, you might have, like, when you have like an email form, put your name and your message and we'll get back to you, send that. That would be a post request from that form, which would then send to the web server. The web server would create some sort of event and it would, notify somebody to call you back or email you or something like that. But a post creates new info. Now, these two, and that's what they're supposed to be used for. I mean, you can use a GET to do whatever you want. You can use a post to do whatever you want, but that was like the intended use. So only these 2 guys have been used for years and years and years, even though these other 2 functions have existed. Well, the people who came up with the RESTful API stuff said, you know what, when I'm talking to APIs, I always either want to retrieve something that already exists, or create something new, or possibly update something that already exists, or delete something that already exists. You can pretty much capture anything you might want to do with an API in those 4 things. So why don't we just apply those 4? Why do we need to invent a new standard when we have a perfectly good standard that's been out there for 30 years called HTTP? So the irony is the new kid that's probably been popular for about 5 years now or something like that, this idea of RESTful APIs is based on something that's been there since the birth of the internet. So we just use HTTP to do all APIs. And pretty much any company today that has an API, it's going to be implemented as a RESTful API. Now, sometimes what you'll see is, let's take PayPal as an example. And I won't spend too much time on this, but let me just kind of fill in the last little bit here. So when you use PayPal's API, they will have a generic REST API. That will work for everybody. Anybody that can speak HTTP, which is pretty much every modern programming language. All right, that's the backup plan. On top of that, they will have APIs for specific technologies to make it even easier to work with. So they might have an iOS API that is an implementation of their REST API. But instead of me having to, call the specific endpoints and go and look at their RESTful API documentation and find out what they're providing, I can just create the PayPal object in iOS and say, get current username or something like that, and it'll just get me that information using the RESTful magic behind the scenes. There might be an Android API. There might be a PHP API. There might be a Ruby API. Things like that. Okay, so if we assume that there's only these 4 APIs that they've written in terms of their RESTful API, and we're not using one of those 4 languages, we're not out of luck. We can still fall back and use their normal RESTful API and just write it ourselves. All right, so that's the advantage of a place having a RESTful API. And then they're just nice sometimes by creating some a library that sits on top of that RESTful API to make it easier to use. All right, so these things exist, and it's something we won't necessarily be working with for probably to like maybe the next class, but know that that's something that ultimately, you know, we're going to start off writing these stupid little programs that just run on, you know, the computer in front of us. But obviously, when you think about the apps that are running on your smartphones and running on your computers, they're talking to a lot of other stuff out there, right? And we need to have mechanisms for doing that. Okay. So here, just to kind of finish our web tech discussion, we are kind of talking about, I drew a picture here, and over on the left-hand side, I had our different web technologies. And I threw this list here, which is not an exhaustive list, but this is a relative history lesson on some popular web technologies. All right, so we'll say Perl is very, very old, predated the internet, was kind of the early scripting language used for the internet. And Node.js is, let's call it like one of the new kids, okay? And these are all for the server side of things. The client side is the JavaScript stuff, and I wrote these down at the end of class last time, and I mentioned that actually every single one of these are just JavaScript frameworks. They're not actually new technologies. They're libraries that somebody wrote in JavaScript, the language that's been around since the beginning of the internet, that do some things that make our lives easier so that we don't have to rewrite that. All right, it's, you know, kind of like going and buying a blender rather than, you know, getting a bunch of knives and, and going like that. You know, we get the thing that does it for us, right? All right, so to kind of put these guys in perspective, we'll call Perl a scripting language that predated the internet, that was initially used, and this is in terms of the internet, to process web forms through what's called CGI, Common Gateway Interface. So not the movie magic CGI. This is the before that CGI, the thing that when you had a web form and you hit the submit button, it sent that information over the internet using HTTP, even in the beginning, okay? And that would go to this common gateway interface thing that knew how to then pass that off to Perl. And Perl then became your server-side language that processed that web form and did whatever needed to be done, whether it was sending back HTML or JavaScript as a response, or creating some entry in a database, or firing off an email, whatever it was supposed to do. That's how that kind of stuff, that's how the client-server model was pulled off, you know, back in the 90s. Okay? Now, the issue with Perl, though, is this is a language that was really built as a Unix scripting language. So it was a language built for, you know, folks who were, you know, creating user accounts or doing automated system backups, not necessarily internet things, because it predated the internet. So there was kind of a necessity as we, you know, as the internet started becoming more than just a fad, there was a necessity to maybe have a language that was a little bit more internet centric. And that's where PHP came out. So PHP, I'm going to call it our first web language. Okay? Probably isn't the absolute first, but certainly this guy was the popular one. So let's call it first web language. I don't know that it wasn't the first, but it's certainly fair to say that it was the first that mattered. All right. So first web language that had tools built in for doing web stuff. Things that were common in web pages. Writing something to a database, retrieving something, authenticating users, that kind of stuff. Things that we were commonly doing on web pages so that we didn't have to build everything that we ever needed to do inside of Perl. We pre-built those things in PHP. PHP is also a general purpose, high-level, interpreted programming language, loosely typed programming language, that allows us to solve all sorts of kind of problems, just like Python is. All right, so anything that it didn't have built in, we still could write ourselves, but it already had a bunch of stuff built into it that made our lives easier as web programmers. All right, now I've kind of listed these guys in order of but kind of by year. So Ruby came out after PHP, and Python came out after that, and there's actually some wiggle room in there where the languages sometimes existed prior to when they were applied to web stuff. For instance, Python was not originally a web language. Still is not only a web language, it's actually used in something called data science pretty heavily, but I'll mention that at some point once we get into the Python stuff. But some of the weaknesses with PHP is this guy required basically a server-side setup before you could code. So you had to have a whole web server set up that had the PHP module on it so that you could even test your code. You could write your PHP code in a text editor, but you had nothing to actually run it unless you had your whole server stuff set up. And an issue we have is, and this is really going to be even a divide for many of you. So for instance, how many of you are computer science traditional majors? All right, how many of you are IT majors? Oh, I love those numbers because I don't like IT people. Okay. But these are different sides of the same coin. So IT, I usually say, is 25% creation, 75% using what's been created. Computer science is 75% creation, 25% using what's been created. So typically, as you start angling towards coder versus kind of server guy, what ends up happening is those coders don't necessarily, sometimes you have like the hobbyist interest, but oftentimes that programmer isn't really interested in setting up servers and things like that. That's more of an IT specialist job. That's what they do. They are used to all the configuration stuff and the software patches and things like that. Not that the computer science folks are is stupid about it. It's just kind of off their radar. I guess the internet hiccuped for a second. So now you have this programmer who, and especially in the web world, oftentimes native programmers would call web programmers kind of like coding for babies or something like that. Okay, when I think you can make that, they don't think they're real programmers. Where actually, I think you can make an argument that the typical web programmer is far more cross-trained than the typical native programmer. So a web programmer typically has a design skill set plus a programming skill set. And that programming skill set can vary all the way from, know enough to be dangerous to being a quite accomplished programmer. On the native side of things, typically those folks are reliant on a designer. So they usually write a lot of code. They might be very proficient programmers, but any interface that they try to create is going to look like, like somebody just spit on something and then smeared paint in it, right? It's not going to look good because typically native programmers, that's not their skill set. They're just coders. All right, so I think a lot of times the web programmer people are much more of a one-stop shop type thing. So an issue with PHP is it required you either have a skill set or know somebody with a skill set to set up your server environment and things like that, which takes time. Now, if you've ever coded in PHP today, that problem has been resolved with third-party options. So now you can just go to GoDaddy.com, you give them $5 a month, and you have your PHP environment set up instantly. There's several different applications that are on the internet now that you just download, and it gives you your own little test PHP server on your computer. So you can start programming right away without really having to do anything except double-click a setup file. But understand that that did not exist 20 years ago. That's something that's more of like the last 5 years type thing. Well, GoDaddy's longer than that, but the whole download something to your computer and just double-click on it and now you're writing code is more of a 5 years thing. So this was a challenge with PHP in the early days. Another challenge with PHP is something that I would say it did not, no support for MVC. All right, and we all know what MVC is, right? How many of you have heard that phrase before, MVC?
NBC?
It's right here, that guy. So, once again, in technology, we have all these buzzwords that float around, right? And most of the time, buzzwords mean something simple. We have this, so I'm going to even give you another buzz phrase here. So we have this idea called a design pattern. Has anybody ever heard of that phrase before? Design patterns, you know what they are?
Not entirely. I kind of spaced out while listening to the podcast.
So you just heard it and you figure it means something. It kind of looks at maybe it's like something formal or something like that, right?
Heard choose the right one for the job and forgot the definition beyond that.
Okay. So design patterns are quite simple, and they were invented by academics because, well, you'll see here in a second. So a design pattern is a proposed good solution to a common problem. They all have funny names. Kind of a requirement. So, a couple things to look at here is what does good mean, and what's a common problem? Okay, you know, if I work with the missile tracking team at Lockheed Martin, okay, a common problem might be bringing missiles to their destinations, right? That's not a common problem for most people. So you could have a design pattern of the best, you know, trajectory assist type stuff. Well, how do you know it's good or not? Well, if you think it's good until somebody else says they have something better, right? So really, we have just millions of design patterns. I mean, we all use design patterns all the time. There's a design pattern for the best way to make a peanut butter and jelly. I bet you if we took a poll in here, we probably could come up with 2 or 3 different kind of go-to methods for making peanut butter and jelly. Some of you are going to toast the bread, some of you won't. Some of you put the peanut butter on first, some of you put peanut butter on both slices versus just one. You know, we have different approaches to it. And at the end, what do you have? You have a couple pieces of bread with some peanut butter and jelly in it. As long as it tastes good, we're going to call it good, right? And, you know, we're going to say it's bad if the bread's all ripped up and stuff like that. But hey, you know, it's all going to the same place. So, so worst that happens, you have to wash your hands afterwards. But so a design pattern is really this like loose thing. And it's great for academics. You've heard the phrase before, publish or perish. So academic folk, we have to write papers and, you know, submit them to prestigious conferences. So, you know, it makes us look better. And, you know, we have all these publications and stuff. Well, so the easiest publication to write is a design pattern. You pick some quirky, quote, common problem. You propose a good solution, whatever that means. You name it something really funky. You figure half the people aren't going to read the thing or they're going to zone out or whatever, okay? And it just goes out there. You get published because the people at the conference are going to look at it and say, oh, well, that sounds like a pretty good design pattern name and it sounds techie. I don't want to read this crap. You're in. And then 2 or 3 people who read it, somebody might come along and say, you know, that's not that great of a solution. Here's a better one. And they get a publication out of it too. And then I can say, oh, you know, you're right. That is kind of better. I still got the publication. I've advanced the research by proposing a solution that was then disproved as there's a better solution. All right. So now over the years, though, some design patterns have kind of floated to the surface as being legitimately popular. And we're going to be interested in a couple of them throughout this course, but the one that we're interested in right now is something called MVC. And MVC stands for Model View Controller. Okay? And what this says is it's a good idea to separate the code, let's say the logic, and I'll put in parentheses code, from the interface from the data. It's a good thing to keep those in different places. And really where this was born out of is PHP in the early days. So in the early days, when you have a PHP document has HTML, JavaScript, and PHP all in one document. The PHP portions of that document are the portions that get pre-processed by that PHP module, ultimately producing the original document with all the HTML, all the JavaScript, and then all the PHP stuff turned into the resulting HTML and JavaScript from the running of the program. So the issue is that was probably fine when you had a very simple website. But now let's take a site like, MSN's portal or something like that, where, there's zillions of things happening on the screen at once. And if you look at the source code for that page, if we go to msn.com, do I have it open here? There's lots of stuff dancing around on the page. Well, there's nothing on the page here right now, so it'll take 15 minutes to a week. But if I do a view source on this when it finally loads, you're going to see this gigantic wall of HTML, JavaScript, and other. All right? Just tons and tons and tons and tons of stuff. Now, if you're going back and you're trying to update your program, your PHP logic in that or something, you're now swimming through the interface looking for the one little tiny line of code that you need to change, because it's all just piled in the one big bucket. All right? So we can certainly relate to that in real life. If you have 2 or 3 things in a drawer, it's easy to find stuff. But, we all have that junk drawer, right? Where there's just stuff in the junk drawer. And you have this suspicion that what you're looking for is in that drawer, but there's no rhyme or reason to where it's at in that drawer. So you got to just start, and then you always have like scissors and pins and stuff, sharp things in the drawer. Why do we put sharp things in that drawer?
And delicate things that break easily.
That break easily, yeah, exactly. Okay, so we could all agree that's not efficient, yet we all still do it, right? Most of us, I would be surprised if all of us at some point don't have a drawer that we could call the junk drawer. All right, so, we need MVC for that, where you should have, the good junk in one drawer, the delicate junk in one drawer, the sharp junk in another drawer, something like that. Okay, well, MVC says it's a good idea to separate your stuff, because as things get more and more complex, if you want to change how your interface looks, you would update the interface file. If you want to change how your logic works, you'd update the logic file. If you want to change how your data is modeled, that's what the model part of it means, which is kind of beyond us right now. It's a poor example for us since we don't have that database side yet. We would then update the model over on that side of things. All right, so PHP did not have this guy built in, no support for MVC. Now, similar to the first problem, now there are third-party solutions for PHP for supporting MVC. So that's why PHP is still a popular language today. But for a period of time, we were scrambling to look for replacements. So this is where Ruby comes in. How many of you have heard of Ruby? Okay, well, you've probably never heard it just called Ruby. It's always Ruby on what? Ruby on Rails. Okay, or the cool kids say, I'm a Rails programmer. I'm into Rails. So we actually see it as Ruby on Rails is how it's usually done. So Ruby is a language. Rails is the built-in web server. So Rails fixes this problem, the required server side. So Ruby on Rails comes with a built-in web server, so you can sit down and start programming right away. So it fixed problem 1. Rails also has built-in MVC. So they fixed both of the PHP problems. Now, the problem with Ruby on Rails is you have to do things the Ruby on Rails way. Ruby on Rails has been around for a while, so their implementation of MVC and some of the other things they have built into the language might be somewhat dated. And until they actually update it, you're at the mercy of the way their stuff works. You don't have choices, right? Beginning of class today, you asked me what was my favorite text editor, right? We get to choose. There's 500 text editors out there. We can beta test them, decide which one we like, and go with that text editor. If you're a Ruby programmer, well, you need to use MVC, and you have to use their MVC. That's it. Now, it so happens that their implementation stuff is pretty good. So not a whole lot of Ruby people are complaining, and there's actually some power in everything happening the Ruby way. We can say that there's a complex directory structure. Complex is kind of in the eye of the beholder. It's not that bad. So you have to do things the Ruby way, but with that, they can also make a lot of those choices for you. So generally, somebody who's very competent in Ruby can put together a pretty complex website quickly in Ruby, because so much of the work just happens for you because it's all mixed together itself. And it's also made specifically for doing web stuff. The language is not really a cross-training type language. Okay, so if you're using Ruby on Rails, you're making websites. A weakness today, though, is that, I mean, more often than not, if you have a new business or something, you're going to have a website, you're going to have an iPhone app, you're going to have an Android app. You know, you might have a widget for a toaster. Who knows what? Because now you're in the Internet of Things, right? So you have everything has an internet connection now. So what you're writing applications for isn't just the web anymore. And typically, one of the goals of a software developer is we want to have a single code base. If we have 3 different applications, we have web, we have iPhone, we have Android, there's going to be aspects of those that are going to be native to each that we can't reuse. But we want to take a lot of that logic, and if we can share it among all 3 of those, that means we only have one code base that we have to worry about. When there's a bug, we only have to fix it in one place. That make sense? Well, if we're using Ruby on Rails, that means that guy's just the web side of things. We're going to have another option over here for our mobile side of things. And then we have to get those guys talking to each other. So that can create some complication as well. So we can say that this guy has a complex directory structure and is totally web specific. It did also, though, bring to the table this thing called Gem, which is a package manager. So this allowed you to install third-party gems into your Ruby on Rails application to extend the what was already provided to you by Rails. It wouldn't replace the built-in stuff like MVC, but it would give you additional functionality to do some cool stuff when a new product comes out or something like that. All right, so this is a step in the right direction, a much more integrated product. Now, Python, I'm going to write this as Python on Flask. All right, so Python's the programming language, and that happens to be the language we're going to use in here. Flask is one option for a web server. So we get to, so the kind of the popular one right now is called Flask, but there's 5 or 10 different built-in web server options we can go with for Python. So we're not stuck with Rails like we would be in Ruby. Okay, we have multiple options. For MVC, MVC is supported through products like one of them, a popular one is called Jade, but there's 50 of those, okay, that support this thing. They're called template engines that support MVC. Okay, so you get to shop around, pick the one that's best for your use, and somebody comes out with a new one that lets you do something special that the old one didn't, you can switch. Okay, you can move over to something else. You might have to update some of your code, but you have the flexibility within this ecosystem where, you know, the language and the server are not glued together. All right, and Python also comes with a package manager called pip, which let's just call it equivalent to Rails, or equivalent to Gem. Okay, so you can install third-party stuff with Python. All right, now Python, as I mentioned, we're using it in here first of all. It's a good first language to learn because it really focuses us to get into the structure of the language, and I'll start talking about that right after this slide. But it is a little bit older language. It was really probably made popular by Google. Google was a Python shop for a long time, and then also a Java shop. But Python is very much used in several different capacities today. There are web programmers that operate solely within Python. There are big data or data science people that work with Python for taking a whole bunch of information and discerning, facts from it, stuff like that. That could be, stock predicting or, things like that. So Python is used for many different things. It's also a simple enough scripting language that you can just write little scripts on your computer in Python. Go ahead.
So you kind of are mentioning this a little bit. So why did you pick Python?
It's a very good first language to kind of, I guess, get into, it's C-based, so you're not kind of going way off the rails, I guess pun intended, in terms of a language that looks very different from the language we'll be using next semester. We're going to be using Java next semester. Another thing that's very important with programming is the structure of your program. That is indentation and stuff like that. And when you use a language like Java or C# or C++ as the first language, you know, things begin with curly braces, end with curly braces, and I can tell you to indent in there and stuff like that, but it's not required. It's more, that's for the user's eyes. Where a language like Python forces structure. You know, if you have an if statement in Python, the stuff that belongs to that if statement is the stuff that's indented under that if statement. And if you don't indent it, it doesn't belong to it. Okay, so it really forces you into structuring your code in some sort of interesting way. It's also a very valuable language in terms of resume building. I mean, plenty of places are hiring Python programmers. So it's a skill set. You know, we want you to have applied skill sets when you come out of our program. So you're going to know Python. You're going to know Java. You'll be exposed to Android development. You'll be exposed to iOS development. You'll be exposed to .NET development, maybe even doing some stuff on the Xbox. You're going to be exposed to some virtual reality development with like the Sony Vive and the Microsoft HoloLens. So you get a lot of practical things that'll help you get a job, as opposed to some traditional computer science programs that start you off in C because that's the language you're supposed to start them off in. And fine, there are jobs that exist in C today, but very tiny number. You know, the cool languages today are languages like Python, which are cross-training type languages. I'll talk about Node.js in a second. So Node.js is a really popular thing on the web side of things. And then mobile application development is kind of the top jobs right now. So if you can do Android and iOS development, you can get hired anywhere. It's kind of the punchline. So I don't know, I'm not sure that completely answers your question. Does that give you a starting point?
So we're doing most of our coding like throughout the computer science.
What will you be using? Well, so you'll have me for 3 semesters for the programming classes. You'll be using Python in the first one, Java using Eclipse for the first half of the second class, Java using Android Studio for the second half of the second class, and then the third class will be Android Studio the whole time. Then you'll have an iOS programming class at some point in there. It's a special topics course that'll be an option for you to take. Software engineering class uses .NET. So you'll be using Microsoft Visual Studio with C# as the programming language. The artificial intelligence class might use Python. They might use Lisp. You'll definitely have Scheme in the programming language theory class with me. That's 470, so you'll be taking that like as a senior. So that's a functional language. So we use that to write our own programming language. Let's see, anything else that I can guarantee you'll be exposed to? I mean, we do a lot of hackathons, so you will likely be exposed to a lot of third-party APIs. You'll be exposed to Google's Firebase for a cloud computing platform, maybe Microsoft Azure as a cloud computing platform, various third-party APIs that we use for these 24-hour hackathon things where we put together an app in 24 hours, and then you present it, and you're working. When we go to these things, we usually put together teams of 4. So we have like a junior and a senior, some more experienced folks, and then a freshman and sophomore who, don't have a lot of experience under their belt. So it becomes a learning experience. The teams aren't necessarily put together to win. They're put together to learn. So you might learn more in that 24 hours than you did like in the whole semester, because it's very applied instead of sitting in class and figuring out what's important and what's fun. So, I don't know, does that answer the question? Or at least kick the can down the road? All right, so the last guy here, Node.js. I'm going to rewrite this as JavaScript on Node. And actually, it's called Express, but let's just keep the word Node in there. And this is JavaScript. This is the guy I've been calling JS on the other screen. JS for JavaScript. So JavaScript is the language. And Node or Express is the built-in web server. There is a package manager called NPM, Node Package Manager, and Express is one of the packages you can choose to install. All right, so there are other built-in web servers, but everybody uses Express right now. Big advantage of this guy. Remember, we were talking about server side versus client side, and front end versus back end, or back end versus front end, if I'm going to keep those in the same order. The front end developer, if we go back to this picture here, is familiar with HTML and JavaScript. The back end developer is programming in languages like PHP or Ruby or ASP.NET. Well, Node is a back end technology, just like all the other ones that we're currently listing. Now you have a back end technology whose language matches the same language as the front end people are already familiar with, JavaScript. Now, I've advertised that the language doesn't matter, okay, that all programming languages are the same. But clearly, if you're very familiar with one language, you would like it if you didn't have to learn a new language for the other side, right? If you could just keep using the language you already know. So that's an advantage of Node.js, especially when you consider that audience. That audience being the front-end developers that kind of come in all shapes and sizes, if you will. Some of them are very strong programmers, some of them are very strong designers, some of them are kind of a little bit of both. Okay, so you have a big range of developer skill sets, coding skill sets on that front-end developer side of things. So if you can simplify the move over to the back-end side of things. Now, I'm not saying they'll necessarily do tons of stuff on the back end. But every now and then, a front-end person doesn't want to have to wait for some, geeky developer to go and write something for them on the back end. If it's something relatively simple, they can just do themselves. And if you can give them a kind of a single technology that allows them to work on both halves in a compatible way, that's good. On top of that, Node has something called built-in event handling for real-time events. Which we don't need to get into too much here because we don't have concrete examples to point to, but it's good to have real-time event handling, and it actually makes your web pages much snappier. Things update quicker, all that crap. Okay. Next class, we will finally start talking about Python variables. Where are we at in the book right now? What was the last assignment I gave you for reading? 2.2. Okay. No.
Next class, all done. Come on, we can do it.
Go ahead and do 2.3. What does names do? 2.3 and 2.4. 2.3, 2.4 for Tuesday, and hopefully we can have our first programming assignment on Tuesday.
All right. That's very well.